projects that decided years ago to cluster with the support of the European Commission, particularly of the executive agency, the REA, and GRTD, to maximize, the efforts of projects that worked on and are working on the challenges deriving from water pollution at large. At the beginning, just to have a small introduction, the Zero Pollution for the cluster gathered 7 sister projects, basically focused on drinking water and groundwater. But now, since a bit of time, the cluster expanded to 18 projects and includes quite a diversity of different challenges related to the zero pollution for water. This cluster is important for many reasons, because pollution of water has an impact on not only on the quality but also the quantity, and of course in terms of protection of our environment, where water represents one of the most important vehicles of pollution in our societies. So I'm really happy, that we have important speakers today contributing to this webinar. Figures from the projects focusing on how the Zero Pollution for the cluster and its project can contribute for building a resilient water smart society and economy. And I also welcome Sofia Pachini from the REA, which will give us an introduction on the webinar and on the impact of the zero pollution challenges on the achievement of a smart society and economy, particularly in the framework of the running water resilience strategy of the European Union. Thank you so much, and have a great webinar. And Sofia, the floor is yours. Thank you so much for your contribution.
Thank you, Andrea. Thank you for the introduction. Good morning from me. I am Sofia Pachini. I work as a project advisor at the Research Executive Agency at the Unit of Biodiversity, Circular Economy and Environment. Just let me say a few words about REA. So REA is implementing 7 sub-programs of Horizon Europe with a budget of almost 23 billion euros from 2021 to 2027. And we do that in partnership with 7 directorate generals from the European Commission, who are in charge of the policy making. In a nutshell, I can just say that, our agency since 2010, through our projects, we have supported 23 of the Nobel Prize winners for the last 15 years. We have selected more than 21,000 projects to fund, and we are a big institution, and we're 900 people there working. I'm very happy to be here and welcome you to this Green Week partner session with the title Zero Pollution for Resilient Water Smart Society and Economy, from Innovation to Implementation, Investing in Nature Through Water Systems. There are a lot of keywords in the title, and many of them point to the EU Water Resilience Strategy, published in 2024. So I would like to start from there. The starting point for this strategy is the 2050 vision put forward by the EU and at the UN Water Conference back in 2023 for a water resilient European Union that ensures water security for all. And the strategy actually sets a pathway to make Europe water resilient, which means protecting and restoring aquatic ecosystems, striking a fair balance between water supply and water demand, and guaranteeing access to safe and affordable drinking water and sanitation. The strategy contains more than 50 actions, taking into account environmental, but also economic and social dimensions of water. And it recognizes research and innovation as one of the key priorities areas. The strategy is working on a water resilience research and innovation strategy to address the gaps. And I would like just to point out that this is a work in progress, and there will be very soon a call for evidence. So please mark it in your agendas. There will be a call for evidence for water and for ocean for a research and innovation strategy supporting the water resilience. It will be coming, as I said, mid of June. And the aim is to have the strategy ready by the end of the year. Projects like the ones that we will hear about today are contributing to the zero pollution ambition, and they're actually fully aligned with the third objective of the strategy, of the water resilience strategy, that is safe and affordable drinking water. The projects address challenges such as improving water monitoring, water in cities, which means digitalization and integrated water management. They also target specific pollutants, such as forever chemicals, the impact of climate change in water quality, water governance and management, and safe and clean drinking water, looking also, for example, at disinfection. Most of the projects also target scalability and uptake by different actors and contribute to more efficient policy implementation by working and testing in different environments, dedicated communication, high stakeholders engagement, or even capacity building of relevant actors. I think this has been a central pivot for the more recent European research and innovation programs. So we have been and we are always committed to funding scientific research, but it is now equally important to see this innovation reach the market and meet the demands and needs of the end users to ensure uptake. And therefore, at REA, we invest substantial effort in supporting projects to progress from purely academic research to higher technology readiness and facilitate the adoption of the solution. For this reason, I am really particularly looking forward to the presentations and the discussions and hope to learn a lot from the insights of the projects about scaling the solutions. I hope that you find today's meeting inspiring. I warmly encourage the cluster to maintain its commitment to enhancing its impact and to improving our water resilience and safeguarding water, which is essential for all other activities. So thank you once again for your attention. Andrea, I pass the floor back to you. Thanks a lot for this.
Thank you so much, Sophia. Thank you so much for the past efforts and support that we get from the REA, from the Commission at large, and that passed through. I mean, also not only events but practical outcomes and the results. I mean, from the projects. And from our side, I mean, from the Europe side, we coordinate, I mean, the zero pollution for the cluster. There's the commitment of not only expanding the cluster to the possible extent in order to create a really critical mass of projects and gathering together the experience and sharing experience, but also to disseminate this, I mean, in the relevant places in Europe and beyond Europe, also with other partnerships and initiatives. Now, I think that we start, I mean, the presentation part of this webinar, and I would like to ask Anais, my colleague Anais, to introduce, I mean, the next speakers. Thank you, Anais. Thanks.
Thank you very much, Sophia. It's always a pleasure to have you with us and for your great opening. And also thank you, Andrea, for your opening as well. I am now pleased to welcome the first speaker for this event, which is Ana Pereiro, Project Coordinator of Mar to Protect, one of the funding projects of the Zero Pollution for Water cluster, who will provide us a general overview of the cluster, since Mar to Protect was here since the very first beginning of the creation of the cluster, and the project will phase out in November. So Anna, please, the floor is yours, and let me know if you have any troubles with the screen sharing, otherwise I will do it for you.
Thank you, and share my presentation. You can see?
Yeah, all good.
Okay. Firstly, I would like to thank Andrea and Water Europe for the invitation and the opportunity to Mars to Protect to present some results of the project that contributed to this cluster from the beginning and at in the last step of the execution and implementations. And Mars to Protect is focused in develop integration solution between technological and non-technological tools to prevent the groundwater contamination from the global change and climate change, using a new generation of managed aquifer recharge. The groundwater have a lot of pressure related to climate change and to human activities. Managed aquifer recharge is a very good tool to contribute to increase the quality and the quantity of the groundwater. And in Mars to Protect, we use different water sources for this managed aquifer recharge. This project is coordinated by us in collaboration with other 4 academic institutions, 5 research and technology organizations, industrial partners, technological transfer entity, and public administrations. The core of the Mars to Protect is one decision support system that uses artificial intelligence to improve the groundwater quality and quantity. And incorporate this decision support system incorporate the different results of the different activities carried out in our project. The most important is the development of the novel water treatment technologies for the different water sources, the sustainability analysis of these technologies, different models to predictions of the effects of climate change and global change in groundwater quality, a strong stakeholder and society engagement activities, real-time monitoring, and of course, policy analysis and recommendations. The Mars DSS incorporate also suitable and feasibility mappings for the design the best strategy for the managed aquifer recharge, different models and digital tools for the designs, and a lot of different data from one demo site in Spain, in Marbella, that applied managed aquifer recharge during a lot of years. Using these data and results of all activities, the DSS use suitable site suitability, risk assessment, water treatment, CAPES and OPES analysis, and stakeholders' opinions to design the best strategy of managed aquifer recharge in the 7 different demo sites that we have in our project. These demo sites were selected taking into account the different climate change and political and economical situation of the different demo sites. We have 2 in Portugal, 1 in Spain, other in Netherlands, other in Italy, and 2 in Africa, Tunisia and South Africa. The first demo is in Netherlands. The water sources is surface water, and the pollutants that we study in this demo site is salinity, turbidity, organic matter, and colloidal matter. And the results in this pilot plant that is led by IHC and DUNEA demonstrate a high efficiency in the removal of the salinity and PFAS, and collaborate in the dissemination of the project with different scientific articles, conferences, and events. The second demo site in Tunisia use wastewater effluents as water sources for the Manas aquifer recharge and study the pollutants, diclofenac, bisphenol A, fluoxetine, nutrients, organic matter, and E. coli. And this demo site demonstrate a high removal for pharmaceuticals. We implement a biosensor for the monitoring of the E. coli, and have a lot of living lab, society engagement activities and dissemination in conference and events to take stakeholders into account from the beginning of the project. The third pilot plant is in Portugal, Frielas. We study the water sources is the same, wastewater effluents, but in other completely different environment, and the pollutants study are 3 PFAS and 3 pharmaceuticals present in these wastewater effluents. The technology developed in this demo site are selected for the Horizon results boosters and have a high replication potential because we demonstrate a high efficiency for the removal of PFAS and pharmaceuticals. We applied different modeling application. We have the submission of 1 patent related with this patent, and we have a strong collaboration with stakeholders from the beginning with different living labs and society engagement activities and a lot of events. The 4 demo sites is in Italy, and the target pollutants are diclofenac, carbamazepine, and ibuprofen. And we demonstrate also a very good results for the removal of pharmaceuticals, and we have a strong collaboration also with stakeholders from the beginning of the project. The 5 demo sites is in South Africa and use wastewater and surface water sources as for the Manas aquifer recharge, and we study the pollutants of nitrogen endocrine disturbing compounds and study the ecotoxicity. In this demo site we have 2 technologies. First route, that is the technology to reduce the fertilizer leaching, and 1 biosensor for the real time of the monitoring of the ecotoxicity that have a high replication potential. We decrease the leaching of the fertilizer, and we increase the uptake of ammonia nitrate in the plants. We apply different modeling tools to design the Manas aquifer recharge. We have 1 patent application also, and we have a strong collaboration with the stakeholders from the beginning. The 6th demo site is in Marbella, led by Z1 Aquatech, and the sources is groundwater. And this is completely different demo site because we was used as to design the first strategy for the design of the Manas aquifer recharge and the DSS of our project for the replication in the other demo sites. In this demo, we develop different suitable and feasibility maps, tools, and models, and to design the decision support systems for the and the different modeling tools for prediction of the climate change in the next, the influence of the climate change in the groundwater quality in the next years. And these models are incorporating, of course, in the decision support system. And in this demo size, we select 2 technologies for the Horizon Resource Boosters because have a high replication potential in the decision support systems and the risk tools that is related with the prediction of climate change influencing the groundwater quality. And have also a strong collaboration from the beginning with the stakeholders for the design of the decision support systems and this modeling tool for the prediction of the climate change. And the last demo site is an example of the nature-based solutions in Mar to Protect that use surface water in the Lima River estuarine to apply phytoremediation for the removal of the pharmaceuticals, metals, and nutrients. And the resource demonstrates that the nature-based solutions are also a very good technology for the removal of these emerging pollutants. And this demo site has also a very strong collaboration with the stakeholders from the beginning of the project. And the impact of our project can be shown in this table with a lot of interaction in the social media, different articles in media and interviews, different videos related with the project, a strong collaboration with the sister projects in the clustering activities in the Zero Pollution for Water cluster and ICT for Water cluster, a lot of living lab interactions with more than 100 stakeholders per interaction in all living labs, and a lot of society engagement activity with a high participation, because Mar to Protect in this moment we have more than 7,000 participants in all events related with the demo sites. And this is very important for the better design of the solutions in these demo sites. Of course, and it's important the contributions for and collaboration with the cluster in the different policy recommendations for related with, in this case, the groundwater protection, with the highlight of the nature-based solution to mitigate the groundwater pollutions, and the importance of the monitoring of the different emerging pollutants for the to quantify the groundwater quality. Related to the water scarcity, in this same policy briefs prepared in collaboration with the Zero Pollution for Water cluster, we have the different recommendations for the reclaimed water as sources for the managed aquifer recharge, and highlight that European goals need to reuse the water to can increase the groundwater quality and quantity. Related to managed aquifer recharge, Mar2Protect has two different policy briefs specifically related with this point to highlight that European water policy needed to incorporate the MAR strategies in order to have the same implementations and requests and processes to use these solutions as a very good approach for the groundwater protections. We have in the last step of the last policy brief related to Mar2Protect policy briefs related with the contaminants of the melting concern in the groundwater. And we have these policy briefs available in the end of this year. And of course, we have a collaboration for the digital monitoring and control in one policy brief of the zero pollution for water cluster of the beginning. And of course, as taking into account as example, the last digitalization action plan carried out for water Europe. Okay, and thank you all for your attention. This is all.
Thank you very much, Anna. I think that the great results carried out from the project talk by themselves on how successful has been the project so far. And thank you also for your great contributions that you have carried out also within the cluster activities. So thanks a lot for this. To the participants, if you have any questions, I kindly ask you to put them in the chat and we will be able to have a dedicated session later on to explore them. We can now move on to the next session, which is the thematic spotlight session, where we will have 4 projects providing different insights from their perspective. I would like to call now the project Aquamon, represented by Angelos Giokas, Dissemination Manager. Aquamon is one of the most recent projects that has joined the cluster in early 2026. So we are very much happy to have you here on board with us. And Angelos, the floor is yours. And of course, if you have any issues in sharing the screen, I can do it.
Okay, let me.
So if you prefer, I can share the screen for you.
No, it's okay. Can you see it?
Yes, perfect.
Okay, yeah. Thank you very much. I'm Angelos Giokas. I'm from the Aquamon project. I'm the dissemination manager. We're quite a new project. We just ended our first year, so we are still in the elicitation of the requirements of the project. And the second and third year will be moving on the technological development and validation. So the presentation is divided into 3 sections. The one is the urban water quality challenges, then the proposed framework of the project, and a presentation of the use cases. So for the challenges, the urban water pollution is very important, especially in the latest year due to the rapid urbanization and the industrial growth. Also the intense resource pressures and also affected by the overall climate change. And the impact of this is that we have altered water dynamics and also nutrient pollution in the surface and the ground water. This causes damage to aquatic ecosystems. It harms the biodiversity, but also affects the public health. For instance, it can facilitate the spread of diseases. Now, what are the critical gaps? The first is that we have a slow and manual methods, such as manual sampling. The lab tests are expensive, and also we have misses in this test. We have sparse sampling coverage, so we have insufficient density that it's making difficult to track in an efficient way the ongoing degradation of the quality. The third is the regulatory demands. We have new directives like the Urban Wastewater Treatment Directive, directive for high resolution data, and this compliance should be mandated by 2035 to 39. And the integration gap, how all this data that is captured for monitoring is integrated, and how we can use open data and artificial intelligence in order to make predictions, modeling, etc. So, what are the Aquam framework? We have three nested layers starting from the sensors. So we develop specific sensors for the monitoring of the water quality. These sensors are combined with robotic solutions so that the sampling can be done automated, and also with the robotic you can navigate into many areas of the urban water. And finally, the gathered data is fed to explainable AI models and the digital twins for analysis and prediction. Now, for the sensors, we have three main categories of sensors. The one is for drinking and surface water, that measure some chemical parameters, and for microplastics, wastewater and the sewers, that are IoT devices that monitor elements such as nitrogen, ammonium, E. coli, etc. And for the infrastructure monitoring, for instance, to measure spatial temperature, that can locate anomalies, etc. The second is the robotic solutions. We have LUVs to scan pollution plumes, USVs for shallow waters, and UAVs for aerial monitoring. And the AI and digital twin infrastructure. First, we have a centralized data lake that gathers those data and provides AI analytics. We have a 4D digital twin that visualizes all this data through a command and control interface. And we also provide semi-automated decision support that can help the water management entities to make a decision and actions. So in one word, let's say our main objective is to develop and demonstrate a whole system, a pipeline, starting from the sensors through the robotic mounting of the sensors to a digital platform for real-time water monitoring. We have 5 use cases that will apply these technologies. The one is Lviv in Ukraine, Paris, France, Limassol, Cyprus, Turin, Italy, and London, at the Thames River in the UK. Thank you very much. I hope I was on time.
Thanks a lot, Angelos. You were on time perfectly, so thank you very much. I would now like to give the floor to Mireia Marseille-Escalais, project coordinator of Life Pristine, which is one of the 3 LIFE projects that also joined the cluster in 2025. So Mireia, the floor is yours.
Thank you, Anais. I'm going to try to share the screen. Is okay?
Yeah, all good.
Okay. So, hi, I'm the project coordinator of Life Pristine, a project that aims to develop an alternative, sustainable, and modular solution for the removal of micropollutants in wastewater treatment plants, but also in drinking water plants. Okay. No, okay. So all the water sector is familiar with the challenge of the contaminants of emerging concerns. And these substances are anthropological substances that are persistent and mobile, and that may pose an adverse effect on the environment and also to the human health. So thanks to the latest advances in the technological and analytical technologies, we are able to have like more exact measurements, the detection, but also now we are aware that our current treatments are not completely efficient to remove these contaminants. So in this context, the Life Pristine was created or was born. As this presentation is focused on the implementation of innovative solutions, we wanted to identify some implementation drivers and barriers that are selected for Life Pristine, but also we think that can be extended to other projects. The first barrier is the evolving landscape of target compounds. So as the detection capabilities have increased and have improved, the list of the targeted compounds is changing, is continuously changing. So that makes difficult to identify a single treatment or a single technology for the complete removal of all the target compounds. The second barrier is the technology integration. So we have a lot of existing infrastructure. How we can combine the new technologies in the existing infrastructure. This integration sometimes is complicated and challenging. And then the cost. The cost is also important. And sometimes the new technologies or the new solutions that have higher removal efficiencies cannot compete in terms of cost with the traditional ones that maybe they don't have like high removal efficiencies, but they have moderate removal efficiencies. What we have in our favor, what are the key drivers? The European regulations. But here I put only the European regulations And as Sofia mentioned, it's also important to consider all the water strategies as the water resilience strategy that can help to promote and can help to implement new solutions and new technologies to comply with the regulations and the requirements. Then the public perception. We think that society is more aware now about the long-term impacts of these contaminants of emerging concerns on human, but also in the environment. And finally, the improved detection capabilities. So the progress in these detection capabilities can fit and can help the European regulations, but also can help to monitor the removal efficiency of our solutions, because then we can check what we have removed, and all the process. So as one of the main important key drivers is the water policy, or the European water regulations. Here we wanted to show the main regulations that affect our project. So the cornerstone is the Water Framework Directive that aims to protect all the water bodies, rivers, lakes, transnational waters, coastal and groundwater, to achieve good ecological and chemical status. And from this directive, we obtained, or this directive gave rise to the other ones, to the revised urban wastewater, the water reuse directive, the drinking water directive, and also the environmental quality standards directive. What they have in common, that they are limiting the micropollutants concentration. They are monitoring a lot or some compounds. They are also including risk management harmonization. They also have an assessment of the whole supply chain to ensure safety, and the revised urban wastewater directive also include the extended producer responsibility that can help to make some of the new solutions more affordable for utilities. So when we were planning the project, we checked the technology options for the micropollutant removal, and depending also on the maturity level. And we chose existing technology, and we propose modification and improvement of this technology, because maybe we have the technology, but we need to improve the energy consumption. We need to improve the cost of this technology, and we need to improve also the removal efficiency. We also thought that a combined treatment was more efficient than a single technology treatment. So we combined some of this technology. And I also include here the revised Urban Wastewater Treatment Directive, because the project was proposed before the revised legislation, but we aim to achieve 80% of the removal. And here we have our solution. So our solution is formed by a UV-LED IOP, an AI sub-sensor, the hollow fiber nanofiltration, and encapsulated absorbance. But all of the technologies have some improvements to try to be more easily implemented. So then, how is the project rationale? We think that our project rationale is very aligned or is completely aligned with the live program, because demonstration activities give us data, results, evidence that fit the impact, the impact activities. So we can check, we can assess the environmental benefits, the social benefits, and also the economical benefits. And with the results plus the impact benefits, we can fit our exploitation route, our business model, and also the requirements or the capacities for replication. Another thing that we consider that it's very important is the communication and dissemination to engage stakeholders, but concretely the focus groups and the awareness campaign. The focus groups, because then we have information about the perception of important stakeholders, and we can improve our solution, or we can have information on how we can implement it. And the awareness campaigns, because there are still some barriers regarding the perceptions on reuse and also on water safety, that through these awareness campaigns we can work to try to modify it and to be more close to the general public. So all these activities, from the demonstration, the impact, all the sustainability, exploitation, and communication, we think that helps the market uptake and the technology deployment. And that's all. Thank you for your attention.
Thank you very much, Mireia. Thanks a lot for your great insights. We can now move on to the next project, which is Niagara, represented by Jaume Cotolí Sancho, Work Package 3 leader. I will share your screen.
Yes, please.
Okay.
Okay, so hi everyone. I'm Jaume. I'm working at Global Omnium, one of the main water utilities in Spain, and I'm going to present Niagara project. So next slide, please. So we did expect it that people affected by chemical pollution of drinking water will increase up to 2.5 billion in 2050. This is the consequence of rapid industrialization, even more rapid urbanization, and increase of intensive livestock for an increasing global population. So us in water utilities face a series of threats. Next, please. Being the first one, the under-evaluation of risks, and this is because only 2% of emerging substances on the non network list are currently regulated as emerging pollutants. This means that hundreds, even thousands of hazardous compounds, including ubiquitous pharmaceuticals and endocrine disrupting pesticides, are not routinely monitored by drinking water treatment plants. This means that these substances circulate in trace concentrations that slip below standard priority thresholds, but are still potent enough to cause long-term biological damage. The second threat would be the presence of nano and microplastics. Due to their microscopic size, these particles that come from industrial and domestic runoff easily pass through conventional filtration stages in waste and drinking water treatment plant. So concentrations of thousands particles per liter have been quantified in European tap water, leading to an estimated human intake of thousands of particles per year. And once inside the human body, they can cross critical biological barriers like the intestinal or the blood-brain, causing neurotoxicity and acting as hazardous carriers that can transport other toxic chemicals and even pathogens. The third threat would be bacteria prevalence, as for example, Helicobacter pylori, that is a type 1 carcinogenic. Standard microbiological controls in drinking water are outdated, focusing almost exclusively on Escherichia coli and Enterococci. And the heavy conventional use of chlorine in treatment plants has triggered the rise of chlorine-resistant bacterial strains. For example, Helicobacter pylori. This pathogen easily survives standard disinfection protocol, colonizes water plant biofilms, and has been detected in almost 40% of drinking water samples in Europe. The next threat would be insufficient analytical methods. So conventional water safety relies on discrete retrospective laboratory testing that cannot catch sudden contamination events or complex variations as they happen, because standard routines lack the sensitivity and the multi-analyte capacities required to detect complex chemical mixtures simultaneously. So we, as operators, we need urgently automated and real-time alerting tools. And the last one, regarding all of the previous one, is the need to identify appropriate management actions for these new situations. Traditional chemical disinfection is no longer sufficient because it actively reacts with organic micropollutants to form toxic unregulated disinfection byproducts. Also, chlorine reacts with common compounds like, for example, paracetamol or bisphenol A to generate halogenated variants that are significantly more toxic than the parent pollutants. So we, in the water utilities, must shift towards risk-informed and multivariate strategies. So next slide, please. And this is why Niagara comes into action. This project was funded under the 2022 call. Well, actually, it was the first in the reserve list. So those working in European projects will know this feeling. It's expected to end in October of 2027 with a budget of 3.6 million euros and 11 partners from 5 different countries. Next, please. And our goal in Niagara is to develop one solution for all the above-mentioned threats and integrate them into a comprehensive pilot demonstrator that will allow us to monitor and remove chemical biological pollution present in European drinking water, as well as manage and minimize the risk associated with this presence. Next slide, please. Okay, Niagara is built upon 3 vertical pillars and 1 transversal one. Our first pillar addresses a major vulnerability in water safety, that is the time barrier. So in this project, we are developing some biosensors for real-time monitoring of the water quality. Also, we are developing novel drinking water treatments based on enzymatic degradation systems, and also pilot-scale novel heterogeneous photocatalysis system. We will also validate all these technologies in tandem at a pilot scale, in a pilot plant. And then we will carry out some advanced modeling and data treatment that will allow us to gather and all this information that is generated and provide us with tools to adapt our water management. Next slide, please. So as the validation leader in the project, we are testing all these solutions in one of the most beautiful places at least in Europe, that is Valencia, Spain. Next slide, please. We are building a pilot plant that will allow us to include all these biosensors that will monitor the presence of Helicobacter pylori, but also imathalil, that it's a fungicide that it's widely used in the Mediterranean arc to treat some fruits like oranges or tangerines. We'll also monitor bisphenol A and paracetamol and ibuprofen, that are compounds that are easily found when because of human contamination of waters. So I am going to show you just a quick slide on results. Next slide, please. So we have validated in a first stage this treatment using phenol as one of model compounds. Phenol is one compound that can be easily found throughout the degradation of aromatic organic matter. And what's more important, it's our system. It's capable of eliminating complex mixtures of imethylene, acetaminophen, and bisphenol A easily within a few hours, going way below detection limits of very modern analytical techniques. And next slide, please, the last one. Also, one of the major developments in this project is the digitalization, because we are developing a modeling tool to be able to monitor dissolved chemical pollution, not only within the pilot drinking water treatment plant, but also in a pilot sector of the drinking water distribution network of the city of Valencia. This modeling is based on a smooth particle hydrodynamics model. And with our knowledge of network modeling, plus the modeling of the possible presence of disinfection byproducts, mixed with real-time water quality monitoring, will allow us to have real-time knowledge and will enable us to take further action to protect our drinking water. So this is everything. Thank you. And thank you, Anais, for the help with the slides.
Thank you very much, Jaume. Thank you a lot for the overview and of Niagara project and its missions. For this session, we will now move on to Empower with the Miguel Angel Suarez, project coordinator of the project. And so, Miguel, the floor is yours, and I will as well share your screen.
Thank you very much, Anais. Thank you very much to the attendants. I'm Miguel Ángel Suárez from the Technological Center of Energy and Environment in the region of Murcia, and I'm the project coordinator of the project Empower. Next slide, please. Project Empower is it has a difference with the other projects that have been presented before, is that it's not only focused on water, even though the water is the origin of Project Empower. As I mentioned, we are located in the region of Murcia in Spain. It's an area with very high water stress. It's very dry, but there is also a lot of intensive agriculture. Actually, this area is called also the orchard of Europe, and it's very important to keep the water quality for the different uses that are in place. Besides this, we have a unique geography with a coastal lagoon called the Mar Menor, that is the biggest salty water lagoon in Europe. So coming back to agriculture, we know that fertilizers are essential for life. Nitrogen and phosphorus, they are key to ensure the growth of vegetables, of trees, and even of ourselves as proteins. But when there is excess of nutrients, they can accumulate and lead to ecosystem damage. This is called the phenomenon of eutrophication. When we are talking with a coastal lagoon, this effect is even more dramatic, and the excess of fertilizers used not only in agriculture, but in other economic sectors can cause that the ecosystem collapses, as it happens, and you can see from the pictures there of the eutrophication in episodes in Mar Menor, called also as the green soup. So it's important to have regional adapted solutions and have a proper and circular management of nutrients so that we can benefit both the ecosystem and the agriculture, because the excess nutrients that are finishing in the Mar Menor, they are the nutrients that are required for agriculture. Next slide, please. So the solution is Project Empower, which has as goal to reduce emissions and restore the nutrient balance. It's a Horizon Europe innovation action that aims to reduce these flows of nitrogen and phosphorus while creating circular nutrient flows across sectors. As it is a complex problem, it has a combined solution. It has a summary of solutions with technological use of best management practices, governance measures, so that they can be demonstrated on TRL 8, close to market, so that they can be useful to control the nitrogen and the phosphorus. It's a 4-year project that started at the beginning of 2025. We are getting closer to the middle, and it's a project that has a very strong regional component with a lot of partners from the region of Murcia and other areas in Europe. Next slide. So the concept has this approach with 4 parts. The first one, to know the problem, is to measure the problem. We need indicators. We need to know the flow of nitrogen and phosphorus in the region of Murcia to understand what are the hotspots and to make a model that can be useful to assess the possible solutions. The second part is the demonstration of 6 circular nutrient recovery technologies to be implemented, all of them in the region of Murcia, and generating 8 recovered fertilizers to be tested in the regional agriculture. Another one are the best management practices existing already in the 5 identified emitting sectors, because there is already a lot of knowledge in each of the economic sectors, so that we don't focus only on the problem, but we try to get on board the different sectors, the different professionals, to learn from them, and also to co-create solutions to manage better the nitrogen and the phosphorus. And last but not least, the governance measures that are essential to keep all the knowledge and all the learnings going, because if not, there is no possibility to continue. It is no point in finding perfect technologies if we don't have governance measures to make sure that the nitrogen and the phosphorus are properly controlled. Next slide, please. So one of the parts in Empower is the co-creation. The co-creation and sitting together the different emitting sectors: agriculture, husbandry, aquaculture, energy and transport, water management, industry, so that we can co-create the solutions to learn also from best management practices. And this is done through the regional clusters, 4 of them, one in the region of Murcia, one in Flanders, one in Finland, and one in Ireland, so that together the research, the academic, the authorities, the policymakers, the practitioners can discuss and can get to common solutions to implement to improve the nutrient flows on regional level or national level. Between each other, inside each regional cluster, there are working groups, also called as multi-actor transition groups, focused on the specific characteristics of each of the economic sectors. Next slide, please. And then coming to the properly technological part of Empower, we are implementing 6 pilots focused on 3 of the most important emitting sectors. 2 of them are focused to the treatment of pig manure with the production of biogas, and also with the treatment with bacteria cocktails and nanobubbles. Another is a nature-based solution based on the cultivation of halophyte plants from aquaculture effluents. 2 of them are focused on the effluents of wastewater treatment plants to obtain phosphate salts and to obtain water rich in nitrogen that can be used as fertilizer for fertirrigation. And the last one is based on the run of water from agriculture. I mean, after the irrigation and after the rain, there are channels where water is collected, so that collecting this water and treating this water so that it does not end on the Mar Menor. So from these technologies, going into a big scale, into a TRL 8, we are expecting, we will obtain recovered fertilizers, novel recovered fertilizers, to be tested in field for agriculture use, so that we can get a symbiosis between the zero pollution concept and the circular economy concept in both the environment and in the agriculture. And next one that I think it's the last one. If you want to know more about Project Empower, you can join. You can check in our website. You can join even the regional clusters if you would like to provide with good management practices in the sectors, or just contact us so that we will be very pleased to discuss with you. So thank you very much. And thank you, Anais, for sharing the presentation.
Thanks a lot, Miguel. And I would like to congratulate you all, because we are perfectly on time on the schedule. So this is very great. Now we, once again, if there are any questions, you can put them on the chat, and then we will answer them after the panel discussion. Before moving to the panel discussion, I would like to give the floor to Evdokia Bayrampa, which is here representing two projects at once. One is D4Runoff and the other one is Universe Water. So Evdokia, the floor is yours to give us a bit of an overview of the project that you are representing, since you will also be part of the panel discussion later. So the floor is yours.
Thank you very much, Anais. I will try to share my screen directly. Do you see my screen?
Yes, we do. Perfect.
Lovely. Thank you. Thank you very much for inviting D4Runoff and WaterSense in this webinar today. My name is Evdokia Bayraba. I was the Dissemination Communication Manager of D4Runoff, and I am currently also Dissemination Manager of WaterSense. And I'm here to present you a snapshot of the two projects, as one is the continuity of the other. So there is a sequence. So D4Runoff has been the official name of the D4Runoff is a data-driven implementation for hybrid nature-based solutions for preventing and managing diffuse pollution for urban water runoff. The project has been ended in February 2026 after 3.5 years. And I'm not here, unfortunately, to give you all the details of this project that has been highly impactful, just what we had focused very briefly. So actually, with partners around Europe, in Denmark, in Spain, Italy, in France, we work together in order to achieve the key goals of this project, which was to create a new list, a new library characterizing new contaminants for emerging concern and other pollutants in the runoff water. So it's actually runoff water. Our partner in University of Copenhagen has found in the pilot sites, which was in Spain, in Italy, and in Denmark, quite nasty things, I must say, that were not at all included in the regulations and our directives, I must say. So I would say that it was very surprising what we have found. And there is a very nice publication on our website. You can see the QR code here, where you can find all the information concerning this new library. Also, the project was aiming to develop this tool, multi-criteria decision analysis, in order to help practitioners and local stakeholders in order to find which nature-based solution was the best in their context, in order to have better urban drainage systems. And part of this tool and data into this tool have been integrated into this AI-assisted platform, where has been tested in also in our pilot sites, and it's another way to optimize nature-based solutions. Also, this tool can be found on our website under the resources page. Also, we had a specific partner who worked in the sensors in order to detect microplastics. I cannot go really into details into this because it's really, really technical, but actually microplastics, so the nanoplastics, the smallest ones. We also achieved to do a lot of work to develop these sensors, and those have been also tested in our pilot sites. And in order to contribute to the directives of the European Commission. We also created the final policy brief that is under review from the European Commission currently, and we hope to disseminate it soon once we got the green light to with you, all the cluster and beyond. And finally, in this project, we like a lot to engage with citizens and specific schools. So we develop a different set of games, physical and online, in order to prepare the next generations about water pollution, but also nature-based solutions. How you can solve water pollution using nature-based solutions in a nice way. Actually, these games have been co-created with the kids in schools, and this was a very fun process, I must say, in the 3.5 years. You can also find information, and if you are interested in some copies, please write to me. Later, I will write some, I will have my contact information. So D4NF has ended, and D4NF 2 is coming, and is WaterSense project. The full name of this of WaterSense is development of innovative decentralized technologies and new co-created governance models for water-sensitive communities. The project has started in September 2025, so quite, we haven't even completed the first year, and will run for 4 good years until August 2029. We're having 16 partners in Europe and South Africa, so I could see another project, I think it was Mar to Protect, that has also a partner in South Africa, in Cape Town, if understood well. So it will be nice to work together or meet or bring together our connections. The demo sites, 4 demo sites in Spain, 1 in Portugal, in Lisbon, 1 in Greece, in Naxos Island, and 1 in South Africa, Cape Town. Briefly, as I don't have a lot of time, it is a very ad hoc presentation. WaterSense aims to develop, to co-design a new governance framework together with the policymakers and implement in the case study regions. This is what we are doing currently right now. And this framework will be also, will provide some input also for the decision-making framework and other tools to help authorities, municipalities, in order to find the best decentralized water management systems. Also, we are, as I said, in D4NF, we created this AI-assisted platform, and this platform will be also enriched. And here we have the new version of it, more focused, called as AI-enabled decision support system, specifically for decentralized water management systems. And this is actually what it's like kind of the AI tool too, from D4NF to WaterSense. And of course, we'll have also other activities, the life assessment, the life cycle costing, and social life cycle assessments. So in order to measure the impacts, social impact, economical impact, for upscaling purposes. WaterSense, and as I mentioned, we are currently in that stage of engaging with stakeholders in order to co-develop our governance models and also the decision support system. There are 2 ways of doing it: consultations and our survey and webinars. Our last webinar is going to happen on the 8th of July. It's focused specifically on replicability and upscaling. So we are going to have it like joint with other projects. So if any of you are interested in in disseminating your projects, please write to me. Here you have my email, and we can develop this webinar together. It's happening 8th of July, and I can guide you through the process, so you can provide your expertise in case you are also a project that's towards the end or middle term. And also, if you are having water utility companies, or of course you have water utility companies and other experts in water management, here is our QR code for the survey. So please feel free to spare 5 to 10 minutes in order to help us build our tools. It will be highly important. And lastly, we have the first open day in Lucca happening next week. And if you are interested in participating, you can do it either in person, which is like a bit difficult because you need to book everything in advance, which is not possible, but also we give the possibility online. Here is, you can find information under our blog, and visit our website, write to us for collaborations. We are very open. Follow us on LinkedIn and Blue Sky. We don't have Twitter. And this is my contact information. Thank you very much for inviting me in this webinar. Dear Anais, the floor is yours.
Thank you very much. I know it's not an easy task to converge two overview projects in such a short time, but you did it, and thanks a lot for this. So now we can definitely start the panel discussion, which is aimed to explore how the solutions coming from the Zero Pollution for Water cluster project can move from pilots to real impact. So I have for the panelists, I have a first general questions, which will be the same for everybody, which is achieving zero pollution requires not only technological innovation, but also collaboration across sectors, governance level, and stakeholder groups. In your experience, what types of partnerships or enabling conditions are most essential to accelerate the transition from pilot projects to real implementation and long-term impact? So if there are any volunteers to first reply to this question, feel free. Otherwise, I can call you as you appear on my screen.
I can start, Anais.
Please.
Okay. In my opinion, the collaboration with all stakeholders, the industrial, NGOs, policymakers, and as local association, is crucial, okay, for the implementation from the beginning of any project, okay, because the collaboration with these stakeholders give you the essential tools for the more useful design and optimization of the solution of the specific solutions that need this pilot plan, okay? And the discussion with all policymakers at local level and European level are crucial for to contribute for the water strategies, as Sofia Passini explained, and in order to increase, of course, our impact in our projects.
Thank you very much, Anna. Thanks a lot. Who
Okay.
is willing to go next?
I can follow if you want. I will add that as Pristine is being demonstrated in Spain, we also consider that it's crucial to collaborate with water authorities, at least here in Spain, because they are plan owners in a lot of cases, and they know the requirements, they know the needs, also they know the capabilities of their plan. And also regarding my presentation, they also have existing infrastructure, and they know how we can adapt our technologies to their existing infrastructure. So for us, it's very important to collaborate with water authorities. Even we consider also important to collaborate with technology providers that can provide novel and more efficient technologies, and other stakeholders that are also important for obtaining a good solution.
Perfect. So we should start from a strong governance context within which we will have to involve all the other stakeholders.
Okay.
Thank you very much. The next one?
Okay, I can go.
Yeah, sure.
So to expand on what Mireia was saying, also from the perspective of another water utility, I think that technology innovation, it's only about like 20% of the journey, and the remaining 80 it's pure governance, risk management, and building trust between stakeholders. And we need to establish, in my opinion, 3 essential conditions. And it's the early co-creation partnerships between utility and technology providers. Also, trust-based data ecosystems to overcome commercial barriers. And also front-runner regulatory alliances based on multi-level governance. Because achieving the zero pollution is not about designing the best technology, the most elegant reactor inside the most fancy laboratory. And it's really about creating a governance framework where utilities can also share data securely and adapt hardware modularly to local water chemistries. And also most important, to receive the regulatory backing needed to turn these pilots into operational assets.
Thank you very much. I think you covered 2 important points, which are the co-creation partnership from the early stages and the trust-based approach. And I think that involving stakeholders from the very first beginning of any kind of initiatives or activities, it's, let's say, the easier way to trust to build the trust among the different stakeholders. Thank you.
I can go.
Sure.
Please.
Yes.
Okay. I would say that my reaction is to what has been said just before. This building trust is very key, I must say. From projects, already we have some learning outcomes, and these outcomes is like this early engagement with stakeholders, but really early engagement, because we find a lot of barriers in the process. It's very difficult to reach them. And also in Europe, we are a bit fragmented in the way in terms of languages. So we are having, and we rely a lot. My role is dissemination manager. So it's very difficult for me to reach out to all the target groups without the help of local, well-established connections. And these are the connections who will lead us later to get what is called like a governance model, a multi-actor involvement, etc. So I would say that having good network works, and this is a kind of thing that helps a lot with trust, I must say. Otherwise, and as external, it's very difficult to intervene and convince. Thank you.
Thank you very much for having completed what has been said just before. And indeed, the local help is also one of the essential elements to be sure that the projects are efficient and the solutions as well. Miguel, please.
Thank you very much. Most of the points and the aspects that have been already highlighted, there are essential and for the implementation and the uptake of the innovative solutions in water treatment. I would like to add, when we are talking about innovation, it's also very important to consider who is the promoter of the project. Especially in the water sector, this is not an issue normally, because the big companies in water management normally have the will and the capacity to implement these kind of new solutions to fulfill the requirements of legislation. But if the technology provider is someone a bit smaller, a startup, technological center, then things might get a bit more difficult. So it's very important to have the good partnership between technology providers, between the companies, and of course the authorities, because each drop of water has an owner, and it's required a permit for that. Another point that I would like to highlight is that depending on the project, but normally when we are dealing with the public water domain, we are under the public conditions. I mean, and in some cases, this requires going into tender processes, into procurement. So it's also important that the tenders, the solutions are oriented in such a way that they can provide the best benefit for the community. I mean, we are used to projects where we are developing a specific technology for a specific problem. When we are dealing with public water, sometimes it's required to open a bit the range of solutions to solve a problem. For private water treatment, this might not be an issue, but this is something that I wanted to highlight. And a third, last one, the investment. If investment is very high, then we need to work very, very much in the stakeholder engagement and in convincing the investors.
Thank you very much, Miguel. I think that the point that you highlight, which is that the solutions need to provide the best outcomes for the community, it's very important, because the community in the end will be the users of the solutions. So the solution needs to be addressed, of course, to the problem, but also to those who will benefit from it. So I think it's an essential point that you highlighted. Thank you very much. Thank you very much for bringing your different perspectives to the table. And we can move on to have more specific questions for each of the project. And we start with Niagara. So one of the major challenges for Horizon project is moving from successful pilots to broader uptake. Based on Niagara's experience, what are the main barriers and enabling factors for replicating innovative solutions in different territorial and operational contexts?
Thank you for the question. So at Niagara, we transition our monitoring and remediation technologies to a real-world pilot at our facilities. And we are confronting this so-called the valley of death between successful pilots and market replication. So in my experience, I would say that matrix variability and data sensitivity are key barriers between implementing this solution in different regions of Europe. And but also modularity, creating digital twins, because technologies shouldn't be developed only by technology providers, but it must be co-created within operational realities of the different utilities to ensure that it actually solves pain points from the very beginning. So moving from pilot to market, it's not just about scaling up the size of a specific reactor, for example, like in our case, but it's about building flexible hardware that can handle matrix interferences and adaptive software that respects data governance while proving, and this is important, a tangible operational return of investment to the end users. Because yes, we're talking about being more strict in our water quality and building some newer technology, more effective. But we also need to talk about returning this investment to the water utilities in this case.
Thank you very much. I think indeed that the part where technologies need to be co-built with the reality where they are implemented, it's also very important, because technology only by themselves, they are not much proficient and effective unless they are not taken into account, unless they do not take into account their environment, their reality. Okay, the next question is for Empower projects. So we often hear that innovation moves faster than regulation, while at the same time insufficient regulatory support limits market uptake. From Empower's perspective, what are the main policy or regulatory barriers currently slowing down the transition towards zero pollution, and how can the evidence and results generated by the zero pollution for water projects help policymakers create a more enabling environment?
Thank you very much, Anais, because you are pointing out a very interesting issue whenever we are talking about innovation. That is the regulatory framework. From the perspective of Empower, I can give 2 points. The first one is about zero pollution itself, that in this case, the uptake of zero pollution solutions, it's enabled by a regulatory framework, because in a way it is forcing the authorities and the companies to implement zero pollution technologies to remove the pollutants. That's an enabling factor. From the point of view of circular economy and the reuse of recovered nutrients, there are more barriers, because there is a whole regulatory framework that, even though it is advancing, it might find difficulties when market uptake, if it is not properly included in the lists of the regulations of fertilizers, either on European level or on national level. So that's good for treatment of water, not so good for nutrient recovery and reuse. And there is another part that sometimes we are forgetting, is that some solutions, some technological solutions are actually plants, technological plants, and as them, they need to be studied with environmental impact assessments. They need to apply for permits. The processing and the procedures for getting the permits, sometimes it's delocalized with not so many resources from the authorities, and it can take a lot of time without knowing 100% sure if they are going to get the permit. So even though we can get to the paradox that something that is intended for improving the environment finds a barrier in the procedure of assessing its own environmental impact. Sometimes happens this with other kind of solutions. Maybe the other projects can say about sensors, about nature-based, not so much. But from technological solutions, sometimes we get to that paradox.
Thank you very much, Miguel. I think what you said can also be linked what Jaume just said before, is that sometimes technological solutions are created in a context which is not ready yet to host them and to properly implement them. That's why also technology needs to take into account the reality where it's made. Okay. So the next question is from Evdokia, from the point of view of D4NOF, because you will also receive another one specifically from Universe Water. So
it's water sense.
Sorry, water sense. D4NOF and water sense. Apologies. Okay, D4NOF has now reached its conclusions, providing valuable insights and evidence from implementation on the ground. Based on your experience, what are the key lessons learned from ensuring that innovative solutions and knowledge generated by EU-funded projects actually influence policy implementations? And where do you still see gaps between innovation, regulation, and practice in achieving the EU zero pollutions objectives?
Thank you, Anais. I would say that your question addresses different expertise within D4NOF, I must say. I can only present from my point of view as a dissemination office manager, I would say. You actually point out different aspects. For me, lessons learned is that is also very valid with our discussion today. We need to engage as soon as possible the local stakeholders, because if they are not from the beginning, this will have a huge problem. We will have a huge delays in the project implementation, and this creates misunderstandings, and we're in urgency, and this is something that it should have. We try to do it as good as we could in D4NOF, but as you said, we had some lessons learned, and now we're trying to do it even better in water sense. So this stakeholder engagement could be way more improved in D4NOF, but now we have learned from that. From the policy perspective, we as D4NOF, we clustered, we had different activities with our cluster. So we prepared some joint policy recommendations at the middle stage of all the 3 projects that this policy brief has been developed. But this one had some sort of early outcomes. But it was a kind of base for the final ones. And I would say that in order to create a good policy recommendation, you need also all the consortium to be there to get the point of view of the water utility, of the technology provider, from the society as well, from the researcher. You know, to have a complete idea of the policy you are developing and also to whom you address. And as far as I remember, you also mentioned the societal part. For this, I think in D4NOV we have done a great job, because it was part of our proposal to go into schools, to go into very citizen-focused events in our pilots, and we have seen something very impressive, I must say. The highest number of those who gave a very constructive feedback for our games, it was actually girls. And this is something that we have to always consider in our co-creation processes, and we have to measure between men and women, and to have a community. Let's say, if we want to address the needs of the community, we need to be inclusive. And actually, in all these co-creation processes, we were really taking care, or we have seen this vivid, active mobilization of girls in science, I would call them, but also later in the feedback and the surveys, we have seen way more dynamic contribution for women. So I would say that these are the lessons learned. You go to policy, you go to you create technologies, but also you go to society, because at the end, these are the ones who are going to use your solutions.
Thank you very much, Evdokia. You really mentioned and touched some key points, and definitely stakeholder engagement is essential, but we also need to be sure that the stakeholders involved are equally are inclusive, and there's a balance. So thank you very much. And I think that when you said that the stakeholder engagement can be improved, I think that the lessons learned from D4NOV can be definitely valuable and used for the project Water Sense, which is the continuation, as you said before. So I think it's the great results can be even more enhanced in Water Sense projects now that D4NOV has phased out.
Yes, indeed, I would say.
Okay, thank you very much. So we go now to Life Pristine project. So Mireia, the question for you is, moving from innovation to implementation often depends not only on technological performance, but also on financial viability and market attractiveness. From Life Pristine's perspective, what are the key conditions needed to make zero pollution solutions financially sustainable, scalable, and attractive for wider market uptake? And what role do you see for public funding, private investment, and innovative business models in accelerating deployment?
Okay, so answering the first one, we have 4 key aspects that are the cost, the efficiency, the energy, and the compatibility with the existing infrastructures, and how we overcome or how we approach all these aspects is through demonstration activities, because we need to jump from lab, from this kind of lab technologies to demonstration, and see how we can refine conditions, how we can obtain better results, less energy consumption, and to be able to implement that solution or these technologies. So for us, it's crucial, the demonstration activities in real scenarios and real contexts. And linking that with collaboration and funding, I would like to to note that for us is very important. The LIFE project is important for Pristine, but also for Acciona, because it helps us to demonstrate and to achieve this kind of more mature technologies that they are not in the lab, they are now outside the lab, and we want to demonstrate if it's feasible to implement them in a real scenarios, or what we need to implement them. So for this reason, I think that it's important to keep this program, or maybe an evolution of this program, but with the same scope in the next FP. Because it helps us to implement these solutions that otherwise there are the innovation actions, it's true, but it's another type of project. So for us is quite useful, and it's fast, or the strategy of the LIFE project program, it's aligned with our kind of project. No, we want a technology that solves a problem, and then we want to implement that technology in water treatment plants. So a part of the if we continue looking into the funding scheme, no, we have also the public tenders that we can, and the innovation related to the innovation. No, we also have the public tenders that we can apply, or we can give answers to them. And if we are talking about the funding and the implementation, here we have that in Spain to implement this kind of solutions, or this no, to zero pollution solutions, we need the compromise of the public authorities, because otherwise it's complicated. But it's true that in other countries we have collaborated like with private and public entities for the implementation, for example, in Australia and so on.
Thank you very much, Mireia. I think that indeed it's a very sensitive part, moving from the lab conditions where let's say the conditions are more under control, to real life environment where it's a bit more difficult, than it's the real, let's say, where the project really comes to its active and proactive part. Thank you very much. Evdokia, I am back to you, this time for water sense, from water sense perspective. So we often discuss technical, financial, and regulatory barriers to scaling innovation, but what about the human dimension? From water sense perspective, and based on the opportunities and barriers identified by stakeholders, what role do trust, user acceptance, institutional culture, and stakeholder engagement play in enabling or hindering the wider uptake of innovative water solutions? Sorry.
Okay, thank you very much for the question. You mentioned the barriers, you mentioned the human element, again, the human perspective. I would say that we are very early in the stakeholder engagement, and as I said, we have tried this time to do it from the very, very beginning. Actually, what we try to do, at least until now in WaterSense, is through online consultations and seminars and surveys, and even the open day, is to actually to utilize any means of dissemination, I would say, to go closer to them and engage them as much as we can, in order to create, let's say tailored tools and technologies for them. And we hope that, since we are still in the process, that this will be a fruitful process, and we will have really results that make sense and will really help us to create all these tools based on their needs. I will know a little bit more, I would say, a bit later in the project, maybe after December, where the initial stakeholder process will be completed. About the cultural, you mentioned the cultural, institutional barriers. I'm not sure exactly what you mean by that. Can you specify this element? You
Yeah,
mean
it's
inside the company?
sorry?
I mean inside the company or inside them or the society, cultural aspects that how to overcome them.
Exactly, that was the second aspect. I know it's something, it's a sensitive topic and it's a very broad question, but from your point of view and your experience also in Different, for example, what did you experience? Point of view.
I would say that we have to always heavily rely on the local, let's say, feedback. From our perspective, at least we couldn't. Me as Evdokia in Paris, dissemination manager, I wouldn't be able to do that much, even though I pursue the culture of Italy or Spain or South Africa, that now it's like completely new market that we're addressing without the help and the reference of the of the partners would be very, very complicated, I must say. So I also mentioned that sometimes English is not enough. In order to get input, valuable input, we need materials in different languages. We need, I wouldn't say necessarily the website translated in all the languages of the consortium, but I would say that at least the language of the people you are actually addressing to, it has to be in the local languages. It doesn't matter if this is Estonian or Maltese or I don't know, Swedish or Spanish. It has to be translated in order to have the maximum of impact. Otherwise, the language creates by itself barriers. And this is also another key point I would like to address.
Thank you very much. I think that indeed the language barrier might be something that we do not often think about because we are used to work in English and but sometimes, especially in the water-related sector, some terminologies, some words are very specific to the context, to the sector, and if you do not really understand them, the understanding of the whole system and the activities you want to carry out might be a bit misunderstood. So I agree with that, and also the needs, include the local needs into the activities. It's also another essential point. I do not have any more questions for you, but I would like to know if there are any questions from the participants. I see that there is a raised hand by Rebecca. So I invite you to put your question in the chat. But I wanted also to ask you if any of the panelists would like to react on something that has been said by one another, or to add something more to your replies.
I have a question. There was a question from Miguel, because when it's mentioning about, permits, permitting is it's a sensitive issue because it includes, a bundle of players, actors, because it's but then most of the times, it represents a kind of limiting factor, in the implementation of the innovation, particularly when we go to infrastructure, when we go into to big works, for which there is the need for having complex procedures for having the authorization for this work to be implemented. Do you see that we can work, making, let's say, quicker, faster, more simple, more effective, so an overall legislation at European level, or is something that should be more considered, better developed, better understood, and deployed by the member states or by the regions as well?
The point here is how the governance of the permits is provided in the different countries. This is different for each country. So the agencies that are in charge of studying the permits might have different resources depending on whether they are on one level or another level. Especially here in Spain, is that it's not that we have only one authority on national level, is that many times the permits go down to the level of regional. So it's a very complex governance of getting the same permit in one place or another place. But normally when coming to discussions with companies, with project promoters, all of them, they talk about the procedures and the permits. Besides another factor, because now we are talking about facilities, but when using, for example, a recovered fertilizer that needs to undergo some procedure to register it, and actually for building 2 of Empower pilots, we had to apply for permits. 2 of the 6 needed permits, and they took some months. And we are talking just about pilots, relatively small things. We are not talking about huge industrial scale facilities.
Yes, of course. I mean, when it goes, there to, let's say, the industrial sides, the things could become more and more complex. But this, the question is also for the other panelists. About matter that should the European Union, formulate more effective rules and regulation or directives, for facilitating or improving the capacity of the territories in going through, maybe too much bureaucratic procedures or processes.
I can to answer. I think the key point is the collaboration between all scientific partners, European projects with policymakers and the water utilities and other key stakeholders for to can contribute to European framework with the useful and scientific evidence that support the best approach for the next European policies related to water, for water in general, to increase the quality and quantity. I think that in this moment there are a lot of projects with very useful and important products and digital tools and digital twins and other tools and real-time monitoring that is crucial for the water sector. And I think that the strong collaboration, for example, in the zero pollution for water cluster with the policymakers and with a specific parliamentary session of other type of sessions with policymakers are crucial, and these events is other example of the collaboration with REA and other important stakeholders to can put our results and scientific evidence available for the next European policies. This is my opinion.
Thank you so much, Anna. Any other comments?
I can also provide them an opinion. I'm not a water utility or an expert, as I said, but I've seen the partners of of my consortium struggling with this also authorizations from local stakeholders. The problem is that sometimes the pilots are also built in areas that they also affect agriculture, tourism, and even archaeological places. And there it's the most complicated element, especially in the Mediterranean area. We are all having let's say ancient monuments, and if the pilot is nearby, you need a lot of layers of authorizations. How this can be perhaps be faster. If you propose a pilot that is in this sensitive area, you should have already engaged with the stakeholders in the proposal stage. Otherwise, if the project is funded, you have very tight deadlines that they have to go very, very fast, and local policymakers are not really so they're not so fast. What EU can do with that? Maybe it can provide some recommendations, some tools. But of course, for me, I would say that the most effective solution is to inform about what is supposed to happen in the project, even in the proposal stage, just to save some time, perhaps.
It is understandable, because I mean, then if you have to start from scratch when the project starts, then you might arrive at the end of the project and the permit didn't arrive yet. So this, yeah.
There is a high chance, but we hope not. But especially for sensitive elements like ancient archaeological elements or Byzantine elements, I think that for this, permits can really take a lot of time.
I see that Sophia raising.
Yeah, maybe I can come in because I think the discussion is getting interesting. Well, first of all, the planning and the spatial planning is like a competency for member states, and this is so there is very little room for the European Union to go and tell member states how they're going to be giving their permits. And it's true that, and we have it also when we have innovation actions and we are managing innovation actions. One of the first things we ask before even signing the grant is a reassurance that they have already started the permitting procedure to get their permits to have their demos ready. So this is a clear bottleneck there. I mean, what the EU can do is can give some recommendations, some best practices to the member states, but from there on, it's really a country-specific issue. And I know Spain, because you have regions and a complicated governance structure overall. Of course, this impacts your permitting. The same goes for Germany, for example, which is also different regions and then the federal structure. In other countries, it can be simpler, but it really depends. And it's something that you need to take into account when you design your project.
Absolutely, and it could be also that in terms of added value to project proposals. I mean, showing that.
Yeah, absolutely.
Facilitated, I mean, can help also in having the project approved. It could be, I mean, an additional, really an added value, I mean, to the proposals.
Yeah, for sure.
I think that we are close to the end. I think that we have a couple of minutes left. I mean, I think that we went through quite a few number of important topics and we had, I mean, a really interesting inputs. I guess that it came out, I mean, quite strongly that collaboration remains at the basis of successful implementation, and from research, I mean, to deployment of innovation, from basic research up to the market uptake, I would say. But I will leave, I mean, at the end of Sophia, the final words for this.
Well, I can only compliment you. So you talked about collaboration and how crucial it is from the design, from the very early on project, and everybody agreed on it. I picked up also some other aspects which I found quite interesting. So one was adapting the solutions to the infrastructure. So how you bring in the new solution to an existing infrastructure. I think this is a very interesting point raised, and I keep this one. about also data sharing, interoperability, how you replicate, how you go from one successful example to a wider replication. I think what is important, and I didn't hear it, but I can say it, is actually identifying potential follow-up partners for demonstration cases. I think this is important because this will prolong the demonstration, and you can really demonstrate the impact in a longer term, because usually projects are 5 years, 4 years, 3 years, but sometimes you need more data, more information to demonstrate the solution. If you keep the location, I think it's a positive thing, because also for the community that is engaged, you have a more cohesive, let's say, approach. So yeah, that's maybe my final concluding remark.
Thank you so much.
Thank you all for the very good discussions. Thanks a lot.
I mean, we are at the end. I mean, I think that today we have marked another important milestone with this webinar to achieve a water smart economy and society. Because this is, I mean, our driver, of course, is the water resilience strategy since 2025, and we want really to contribute to that. And to the possible extent with all our capacity in supporting the water sector, so to grow and to improve, I mean, for the current and the next challenges. So once again, I would like, I mean, to thank you on behalf, thank you, the speakers, I mean, Sophia and the European Commission, I mean, for having supported and participated to this event in the framework of the European Green Week. Many thanks, I mean, on behalf of Water Europe, apart from I myself. And I mean, a lot of thanks also to the audience that participated directly to the webinar, so through the social media. So once again, many thanks, and see you soon stay tuned, by the way, for the upcoming activities of the Zero Evolution for the cluster to support, I mean, a water smart society and economy. Thank you so much.
Thank you very much.
Thank you.
Thank
Bye.
you.
Bye-bye.
Bye.